The last recording I tried did not work. It like messed up or something. And then the second period worked, but not, the sound didn't work. So, trying to be better today. What if I wanted to see, so I said this already, if I wanted to see that they equal the same thing, I could set them equal to one another, and once we figure out how to solve, we could solve it, see if they equal the same thing. But without solving it, how would I know that they end up being the same number? Major? Okay, so substitute what? Not a wrong thought. Yes, substitute, but then the what doesn't matter. Someone pick a number. Say it out loud. 4, 7. We'll try both. So let's say we pick 4, and we put 4 into both of these. 2 times 4 gives us, you can say this out loud, 8, and then 8 plus 6 is 14. If I did that same thing over here, and this is going a little out of order with what we're going to talk about because this is order of operation, so we have to do what's in here first before we multiply. So the 4 plus 3 would give us 7. 2 times 7 is 14. So we see those are the same, but that could have been a coincidence. We have to try multiple numbers to make sure it does work. So we'll use the 7. 2 times 7 we just saw was 14. 14 plus 6, 20. And then if we do that same thing over here, 2 times 7 plus 3. 7 plus 3 gives us 10, and 10 times 2 is 20. And I imagine if we kept putting in numbers, it would keep equaling the same thing. So that would be another way to see, are these the same or not? Definitely distribute, work backwards, and divide, and then also put numbers in. Right, just so I can see, if you liked this one more than the which one did not belong, rephrase. Who liked this one better than the last one? A few of us. And who liked the last one better than this one? Okay. There's like 9 different versions of this, so we're just going to play with all of the different ones and see how that goes. It is 10:30, so we have 13 minutes. Alright, so in that, we are going to, first I'm going to delete all of this. Go back to this page, because we did not do division last class, right? And then any word that comes to mind when you hear the word division. Let's go with us, Christian. Quotient. With your hand raised. Can you use your hand raised? Of is more multiplication, so 5. You can do that one. 5 is sometimes multiplication. Yeah, let's not use those two, but if you didn't put that on multiplication, put those there, of and by. I feel like we did. Other words you think of when you hear division, Alex? Divide, dividing, divided. All of those. Major. So then you would be doing, the word would be divide, and then what you're dividing by, then the by would make sense, yes. So you could say divide by, and then those would go together. I'll do it. Oh, to that. Because usually when you split something, you're dividing something. Any others to distribute? Maybe not in this case because that's usually multiplication, so if you want to add it here. But if you want to think of like the opposite of distribute or maybe undistribute something, undistribute would probably work better. Any other words that come to mind? Some I have are over, like we'll say 3/4. If you half something, you're usually dividing by 2. What are some other ones that we have? Simplify. Usually when we're simplifying something, it is a fraction or we are dividing by something and then reducing it. So we have both simplify and reduce. If you wanted to put fraction, it like implies division. Or if you see a fraction, you are dividing. I think of the 4, dividing is probably the harder one to try and think of more words. Any others that we can think of? So we kind of talked about these parenthesis phrases already when we touched on the word of. I said that it's also used with like sum of, quotient of, difference of, whichever one I didn't just say. That's really what your parenthesis phrases are. Product of, I think that was one of
those brackets.
Like seeing the word brackets or using brackets?
Brackets. Like the same. So.
That would be the same thing, yeah. So usually when you see these words, whatever comes next is whatever the word applies to. The sum of 3 and 5. We're adding those two things together. And there's usually the word and somewhere in there to tell you these two things are what we are doing with this operation. The difference of x and 3. Those two things usually go together. The only reason it says parenthesis phrases, when we are translating, not words, but the algebraic expressions to words, we may want to put parentheses around the product of this and this, so we know it goes together. Turnaround phrases, there's really only one. And it's if you see the word less than. So we'll see that here in a second. But if you see the word less than, whatever comes before these words is going to go at the end. So if I said 10 less than x, I'm really subtracting 10, not x. And that's going to be the tricky part, remembering that with less than, whatever comes before goes at the end. It's one of those turnaround phrases. Right? You may have seen that we are not using these symbols anymore. As we start writing this, for multiplication, we're going to try to avoid the x. I feel like you may have already started to do that. And the dot is usually probably what you have been using. We're going to try to avoid that also, unless there's like a lot of different operations. If we have something that is multiplied, we could use parentheses, or we could just put things next to one another, and we'll go through some examples like that here. So we are going to do some of these, and then a couple of these, and then I'll let you try some, but that might be more so after lunch. We'll see. So we're going to start with 10. So as you're reading these, we need to figure out what words stick out that are operation words. So your addition, subtraction, multiplication, division words. So 10 less than the product of 7 and f. Of those words, which ones do you see are operation words? So and or I haven't answered, Billy. Less than. Less than. And what does that tell us to do?
Yeah.
Okay. What operation does it tell us to do?
It's subtraction.
It's subtraction, yes. And I didn't say that here, but it is.
Yeah.
Any other operation words we see? Matthew?
Product.
Product. And that tells us to do what?
Multiply.
Multiply. So I'm going to put the dot here, but we may not need it, but just so we know the symbol. Yes. Yes, that would be addition for this one. We skipped one. Right, so we want to try and write this in the order in which it says, but when it says the words less than, we're going to be flipping that around. So 10 less than the product, that means 10 is going to go at the end. We know we're subtracting, so we know at the end we're going to have a minus 10. So anytime you see those words less than, think whatever came before is now at the end. The product of, so that tells us these two things are being multiplied together, 7 and f. We could write them with the dot in between, but we don't need to do that. We could just write them next to one another. In front of our subtraction, we would just write 7f. There's an implied dot here, but because it's implied, we don't need to actually do it. Questions on that one? Number 4, the product of a number and 10 increased by 1. What operation words do you see? Alex, I did see your hand. I'm just trying to get more people to answer. Product, and we just found out that that's multiplication. Trying to keep colors the same. Any other operation words? Ava. Increase, and that tells us to do what? Add. Okay. The word number here is always going to be some variable, which is weird. It's kind of confusing, but it can be whatever variable you want. If it does not specify X, A, whatever you want. I try to avoid O, because you might mistake for a 0. S, because it might be mistaken for a 5. T, because plus. Usually all the other ones are pretty good. You won't see me use I or E because those are actual numbers in higher math classes, so I try to avoid those. All right, let's see if we can finish this. The product of a number and 10. A number and 10 are going to be multiplied together. Someone tell me, how would we write that part? Josephine, I did see your name. An X. If you want to use a different variable, go for it. And then increase by 1. How would we write that part? Iman. So the product of a number and 10 increased by 1. And even though it says a number and 10, the order in which we write that is always going to be coefficient and then variable. All right, we'll come back and do number 6 after lunch. Alrighty, let us continue. We're going to move on to number 6. Twice a number divided by 3. What are our operation words?
Multiplication. It would be like times 2.
Okay, so this twice times 2. are there any other operation words? Lily? Divided by obviously means to divide. So I'm going to write the division symbol, but we're not going to actually use the division symbol. We're going to use fraction bars instead. Twice a number, so we're multiplying by 2, and that number can be whatever variable you want. How would we write that part?
2x.
2x. And because we're writing this as a fraction, we want everything to be divided by 3. Okay. Questions on that? So we're going to go through a couple of these, and then in a moment you'll have time to practice some of these. So before, we were given words and had to put them into algebraic expressions, and now we're doing the opposite. Now we're going to be given expressions and have to put them into words. The first way, there's really only one real set way to write them. But with these, there are a bunch of different ways to write these, because there are a bunch of different words for our different operations. So keep that in mind. Not everyone may have the same idea, or write it the exact same way, and that's okay. First, we have to decide what operations we see. That way we make sure we include that when we write it. So if you see an operation, raise your hand, or I have an answer. In number 8. So, where are we multiplying? 5 and z squared. So somewhere we need to know that we're multiplying. Christian? Division. That was more obvious. Now there is something else here that's not really an operation, but we need to be sure that we include it.
Exponent.
Exponent. So we need to make sure we have somewhere in our words that it's being multiplied, it's being added, and there's an exponent. Okay, so starting with this first one, we could write out the word 5, we could just write the number 5, if that part doesn't really matter. I'm just going to write the number 5. And then we are multiplying 5 and z squared. Someone give me a word for multiplication. Ima, I did see your hand. I'm just looking for other people. Times. So these could be as simple as times. If you wanted to say multiply by, use the plus of, we could use those as well. How would we say z squared? That is a z, right? Yeah. How could we say that?
11 to the power of 2.
Okay. So we could say it like that. We could specify and say number z to the power of 2, raised to the second power, squared, all of those different things would apply. So a number raised to the power of 2. I did not spell that correctly. There we go. Someone give me a word for addition. In this case, and would work, but we kind of want to avoid using the word and unless we're using it with like the sum of. This means increase. Okay, so we can say increase. Let's say increase or increase by. Because we also want our sentence to make sense using our grammar rules. And then 16. So I'm just going to write the number 16. Do we have any questions on that one before we continue? For number 10, what operations do you see? Christian? Division, definitely. So somewhere we have to include that we're dividing. Sorry, I keep wanting to mix you guys' names. Cameron? Addition. Addition. I saw a couple hands. Josephine, go ahead. Multiplication, where are we multiplying at? So with our division, we want to worry about the numerator first and then go into the division after. So with our numerator, we have two different variables. How we signify that could be a bunch of different things. We could actually specify and say A and B. We could say a number and a different number. We could specify one and not the other, A and a different number, or a number and B. So I'm going to start off by writing a number A. Someone give me a word for addition that is not increased by. Right. If we want to use sum, we can. We just can't use it right here. We have to use it first. So if we wanted to use sum, we have to say the sum of a number A and, sure. It'll get a little messy, but it doesn't matter. So I'm going to move this before. No, I'm going to try to do. Okay. So the sum of a number A and we need to somehow write that we are multiplying 6 and B. Besides using the word times, someone tell me how we could write that. Come on, I just see your hand move. So, how would you write that in the sentence?
Multiplied by B.
Okay, so the sum of a number A and 6 multiplied to B, or multiplied by B, either or. Right. Now we need to say something about this division, now that we got the numerator taken care of. Someone give me a word for division. Christian?
Over.
Okay. Over 2. Now I'm going to write this and then I'm going to show you what we have so far. And then we're going to change this in a second. So reading these words, the sum of, so I'm adding two things together, a number A and 6 multiplied by B. So I'm adding this together. And actually, in this case, this would work. It didn't work last class because of the way we worded it. But because the sum of is saying these two things have to go together, those are like in parentheses-ish. We don't have to put them. And the over 2 would be fine. If we had not used the sum of, let's say we just said a number A plus 6 multiplied by B, and then we use over 2, it would be different. So, just so you see what I'm saying really fast. Number A, I'm using just instead of number, but it's the same thing. Plus, and I'm shortening this also. If we had just written it like this, this would be A plus 6B, where just 6b is over 2 and not the entire thing. The sum of at the beginning really helps us because that tells us all of this has to go together. Here, if we have something like this, in order to get everything divided by 2, we have to use words like all over 2, all divided by 2, or at the beginning use the quotient of this and this. So if you don't use those words all or your parenthesis phrases, you may end up with something that you don't want. Okay, so that works. Do we have any questions on that? There are 5 problems here. You can try them all if you finish them in a short amount of time and want to. But I need you to pick 2 of these 3 and pick 1 of these 2. If you want to do more than that, that's great. Try those. If you finish, ask the people at your table, what did you get? Talk about, is yours similar, is yours different? And then we'll come back in about 5-ish minutes, maybe a little longer, and go through the answer. As an answer for number 1 they want to share, and if you have the same answer afterwards, you can say I agree. So let's go back. N plus 6. Anyone have that same answer? Many of us. Good. I will say if you had the opposite, so let's say you had 6 plus n, this is not incorrect because addition is commutative, so the order doesn't matter, but we want to write it in the order in which it says. So this would be more correct. Anyone try number 3 that wants to share? You guys both raise your hand, but Matthew, go ahead.
2 times b.
And what word here tells us we are multiplying
Up.
So if you did not see that word, make sure you're, I was going to say reading, but you read it. But sometimes of slips through the cracks. That is another one that is multiplication. We could also write these as just next to one another. Another way you may also see this, instead of the v next to, you may see it in the numerator. Those would be the same thing. Right. Anyone have that same answer? Good, good. Right. Anyone want to share their 5? Alex said no. Okay, Christian, go ahead.
X squared minus 7.
X squared minus 7. And you could have used a different variable, whatever variable you wanted. Who had a similar answer, maybe a different variable? A lot of us. Good. If you had switched these and put 7 first, remember that less than, we got to put whatever comes first at the end. Questions on any of those 3 before we move on? For these, you may have more different answers than what the top. Who had an answer for 7 that wants to share? Nature, go ahead.
Power plus 3.
X to the 4th power. What was the rest of that?
Oh, sorry. Power and 3.
And 3. Now I'm going to just switch these because we want to write it in the same order. Now in this case, coefficients come first, so it wouldn't really matter here. But you may see the 3 first instead of the x to the 4th power. Not of, yeah. So you may see it instead the product of 3 and x to the 4th power. Anyone have similar answers to that? Couple of us. Anyone have a different answer or different wording that they want to share or check and see would this work? Okay. Number 9. Anyone have an answer that they want to share? Christian, go ahead.
3 less than the number times 16.
Whoa, slow down. You went so fast. 3 less than.
Number times 16.
That would work. Anyone have the same thing? Or similar? Anyone have something kind of different that they want to share or see if that would work? Alex? Yeah, so you did the opposite of what Christian did, and that's fine. 16 times a number minus 3, and that would still work. Both of those are good. Okay. Anyone else? Cool. We're going to do a couple word problems, and then we're going to move on to something else. But before we do that, how do you feel overall in general about translating? Good? Okay? It could probably use more practice. Not okay? I'm not understanding. Okay. Okay. On to the next page. We're just going to do a few of these. So with these, we're just translating, again, words to algebraic expressions, not actually solving them or finding answers or anything like that. So we're going to read this. Read it with me. I'm going to read it out loud. We're going to start with number 11. You can read it up here or on the paper. Mr. Martinez orders 250 keychains printed with his athletic team's logo and 500 pencils printed with their website. Write an algebraic expression that represents the cost of the order. With each of these problems, we have to start with the variables. The variables are going to be something we don't know. So we have to look at this, and usually in the question or whatever it tells you to do, that's going to help you find what we don't know. So here, we know that we don't know the cost of the order, but that's like in general, total. But that also is going to tell us we don't know the cost of the keychains, each keychain, and the cost of the pencils, each pencil. So we have two unknowns, so we're going to need two different variables. You can call them whatever you want, x and y, k and p, c and p, whatever you want. So I'm just going to use k and p. And when we define our variables, we have to be very specific. Cost of, amount of, whatever we don't know. So cost of each keychain and cost of each pencil. Once we have those variables, then we can start to piece together, okay, what operation words are there, or what are we doing to start making an expression. If we're looking for the cost of the order, we're looking for the total cost. What word or operation word tells us total, or means total? Addition, subtraction, multiplication, or division? Someone said it, but I didn't hear who or what was said. Someone said something, and I didn't hear who or what said it. Which operation would be total? Addition. Addition. So we know somewhere in this we're going to be adding. What this doesn't necessarily say is another hidden operation. Because we know that these represent the cost of each keychain. If I knew the cost of each keychain and pencil, and I multiplied it to each of the keychains I have and each of the pencils we have, we would get the total cost of all of the keychains and all of the pencils. So we're going to be multiplying 250 and k and 500 and p and adding. Anyone want to take a guess as to how we would write this expression? Matthew, go.
250K plus 500P.
That's right.
So here's not asking us to actually find the total costs, because then we do more with it. But we have set up our algebraic expression using our variables and the numbers given. Yeah.
If we wanted to, could we also put like equal and then a variable, like since we're not even.
I would say in this case, we're going to do one that has an equals, but this one, no. If it says algebraic expression, we want to avoid putting equals because that would be an equation and not an expression. But yeah, so in this case, we would just leave it like that. Other questions on that one? Going down to 13, read that with me. Mr. Bailey produced purchased some groceries that cost $3. I'm making up words that I don't see. He paid with a $50 bill. Write an expression for the amount of change he will receive. So in this case, they gave us a variable. We don't have to define it. I mean, we can still define it, but they tell us these dollars. And we can say it's the amount of change he'll receive also, because we don't know either. What operation do we think is being used here? Just subtraction. Why subtraction? He started with 50, and we're taking away whatever the amount is. So we're going to be subtracting. Anyone want to take a guess as to how we would write this expression? Ima? 50 minus C. If we started with the 50, then he paid for his groceries, whatever that amount was, we would know his amount of change. But we don't know that. And it also didn't ask us to find that. Do we have any questions on that one? The last one we're going to do is 14. The volume of a cylinder is pi times the radius r squared multiplied by the height h. Write an expression for the volume. So what don't we know here? Let's start with that. Matthew.
The exact volume.
The exact volume. And we can say V for volume. In this problem, it tells us a lot of our operations, so we don't have to guess or try and figure out what that is. What operations do we see? Lily, I see all of your hands. Lily, go ahead. Multiplication, and what words tell you that? Times, and multiply. Do we see anything else that we need to make sure is in our problem?
Square.
Square. Okay, because everything is being multiplied together, we can just put everything next to each other. So that's nice. I will also change some wording in this because this word is here. And we haven't talked about this yet, but anytime you see the word is, that means equals. So this is actually an equation, not an expression. So this is going to start off V equals. Anyone want to take a guess as to how we would write the rest? You guys are answering so much, and I love it. I'm just trying to get other people. Simone, go ahead.
5 times squared. And then
So instead of writing dots in between each one, which we could do, there are implied dots in between these. You don't have to do that because they're next to one another, so we can say everything is multiplying. Do you have any questions on that? Not right at the moment. We may have time at the end of class. On the notes page for translating, there's a poll. And it says, how do you feel about translating? I know I asked in class, and again, not right now. I want you to answer that poll. I will send that out in the announcements later. That way you remember to do that if we don't end up doing that at the end of class. We are going to switch gears, so if you want to stand up, stretch for a second, you can do that. So the thing we're doing next, I do have actual algebra tiles for you. I don't have them in the classroom right now. So next class, after I show you how to do this, if you want actual algebra tiles to have in front of you, next class remind me and I'll grab those. Some of you may be familiar with algebra tiles and know how to use them or know how they work. Some of you may not, so we're going to test this out. I have to sit down and do this because it won't let me touch it. It's weird. But our goal is to figure out which of these would represent 6x. So some knowledge you need to know if you don't know this already. There are ones, positive ones, those are the yellow squares, positive x's, those are the green rectangles, and positive x squareds. Then we can consider these to be the negative versions of those. They're really red, but they're colored the same, so you see that they are the same. All right? Anyone want to take a guess as to how we would represent 6x, hand, or I have an answer. Josephine? 6 of these?
No. The green ones.
The green ones, okay. 3, 4, 5, 6. Right? If you were thinking 6 yellows and then one of the X, that would have changed this to 6 plus X, and that would have been different. So anytime we have a certain number of X's, I lost my mouse. There it is. Whatever this is, think about that as 6 of whatever it says. Next. 3x then, how would we do that? Victoria? 3 of the positive green x's. Good. 6x we just did, so I'm going to just do that one. 6. Usually it doesn't repeat like this, but okay. Alright, 3x squared. Anyone want to take a guess as to how we would represent that? Christian, go ahead.
3 of the green rectangles. And 1 blue square.
Right. So in this one we have x squared plus 3x. So we have an x squared, but we need to change this a bit. How would we do that? Matthew, go ahead.
Put the yellow tiles in. Two yellow sides.
And did you want to get rid of something?
Yeah, the x squared. The x squared.
So not there yet. Colleen, because I heard you today. 3 of the blues. And are we deleting anything? Wow.
Yeah, everything else.
Delete everything else? Okay. There we go. So just like with our x's, whatever the number says, we need to have that many of the same thing. You guys had good guesses, but this really only has one right answer. Right, negative 5x squared. How would we represent that? Colleen, go ahead.
Five and the light blue tiles.
Okay, this one?
Yeah.
Okay. If I could click, that'd be great. Okay. So anytime we have a negative, same thing, same amount, but the negative version. These will get a little harder here in a second. Right? We're going to do two different, people can answer this. How would we do negative 4x squared? And then someone can tell me how we would do 4. Cameron, go ahead.
4 and negative x.
Okay. And then how would we represent 4? Matthew, go ahead.
4 yellow tiles.
4 yellows. Right, and that did work. So now we're taking like what we were doing before, but combining it with multiple things. Negative 3x squared plus 3. We'll have two different people do this as well. Colleen, you could do one, and then Josephine, you could do the other.
3 of the negative x squared.
Okay. And Josephine? 3 of the yellow. Alright, good. And I think this is the last one before we do more complicated. 3x and minus 4. Liam and Lily. Go ahead.
3x squared.
These ones?
Yeah.
Come on.
Oh no, the green ones.
There we go. I'm going to say, I do whatever you guys say, and then we check it out afterwards. I keep losing my mouse. Right, Lily?
And then 4 of the negative ones.
The negative ones. 2, 3, 4. Good. Right. This one should be, yeah. So now we're going to have 3 people answer. We need a 4x squared, we need a 3x, and we need a negative 2. Nature, Matthew, Victoria.
4x squares.
3, 4.
3 normal x's.
1, 2, 3. 2 negative 1s. Good. Right? That looks similar, but 3 others. Josephine, Kaleem, Linnea, sorry.
4 of the
I think that was 4, yeah.
1 negative x squared.
This one?
No, the green one.
Got it. And then,
And 3 ones.
okay. Alright, we want to do one more, or do we feel like we understand algebra tiles? I see nodding. Is that to the yes, we understand? Yes. Alright. So, we're going to practice this a bit with notes I'm going to pass out. If you feel like you like doing it with the algebra tiles, so again, you don't have that with you, but I'm going to be doing it up here, and you're going to talk me through how to do that. Next class, if you want to actually practice with algebra tiles, let me know, and I can get them for you. The notes you have, you can put those away. We're not going to go through very many of these examples today. We're going to finish them next class. I just want to So So on this page, there are algebra tiles there. If you want to draw in what the final answer is, you're more than welcome to do that. If you want to just draw or write in the final answer, you can do that. And then, of course, next class, if you want to go back and use the algebra tiles, the actual algebra tiles, you can let me know, and I'll get those. So I'm going to come back and talk about this here in a second. First, we're just going to do exactly what we were doing before. How would I draw this or draw this out? Now, instead of doing the red and green or the yellow and red, they're just red. So they're still X's and 1's, but now they're actually negative. Okay, how would we represent X? One of the greens. And this is really 1X. The 1's just not there. How would I represent the 1? Just me. The yellow. And then negative 2X. Billy. Two of the red rectangles. Alright, so we have drawn this or represented this. Match the expression, I think is what it said on the website. Before I continue, that website is on Canvas, so you can go to it and play around with it as well. We want to create 0 pairs. So when we think about those, they're like the additive inverse. But in this case, it would be like a positive and negative of the same kind, a positive negative X or a positive negative 1. Do we have a 0 pair here, something that's a positive and a negative? You could say yes or no out loud.
No.
Do we have positive and negatives of the same thing? Yeah, our X's. So anytime that happens, we're gonna like get rid of them. I'm gonna trash them. Because if we added them together, they'd become 0. So that's why I call that 0 pair. And then we look at what's left. And whatever is left would be our final answer. So we would now, instead of taking the expression and making them algebra tiles, we're going to look at the algebra tiles and say what's left. Anyone want to take a guess as to how we would write that? Iman, go ahead. Negative 1x plus 1. You could also write this as just negative x plus 1. Questions about that? So this would be our final algebra tile answer, but this would be our actual answer that we would write down. Do another. 3x minus 4 minus 2x plus 6. How would we represent this? Lily, go ahead. 3 of positive x's. Victoria. 4 negative 1's. Negative 2x. So negative 2. The negative x's or 1's. And positive 6. 6 of the ones. Do we have 0 pairs here? Yes. How many x of the x's? How many 0 pair x's do we have? You can say this out loud.
2.
2. So we have this pair and this pair. How many of the 1's 0 pairs do we have?
4.
So then this is what we have left. Anyone want to take a guess as to how we would write that? Matthew, go ahead.
1x plus
Or just x plus 2. We're going to do one more of these and then we'll stop for today because I let last class have a good 15-ish minutes. At the bottom of this, we need to represent each of these terms. So starting with 2x. Lily.
2 positive.
3. Ima. 3 yellow ones. Negative 3x.
3 negative x.
There we go. 3 of the negative x squareds. Negative 2. How would we do that one? Or represent that one, Nature?
2 of the red small boxes.
2 of the red negative 1s. Positive x squared.
Only 1.
1 of the blue, that's your positive x squared, and negative x. So
1 negative x. Negative 1, yeah.
negative x experiment, all of those things. Yep. So now we need to find, and I'm going to draw a line so we're not confused. Do we have 0 pairs? So I hear some, yes, okay. Which one? So yes, let's do that. So I heard your voice first and then we'll go. Which one? The green X and the red X. That's a 0 pair. Matthew, you said one?
There's 2x. Blue and white.
The X squared. Any other 0 pairs? Iman? We have 2 of those that we can use, or that are 0 pairs. So then, rearranging this. Anyone want to take a guess as to what our final answer would be?
Yeah. 2x squared. 2x squared. Plus 1 plus just x. Plus 1.
Everyone agree? Anyone disagree? This should be negative because they're right. That was the only thing, but that's all right. Right, so next class I'll show you how to do this algebraically and then we'll practice some more. For the remainder of class, before you check out, if you have not done the Khan Academy that's due today, you have time in class to get that done. If you've already done that and want to continue practicing in this, you're more than welcome to keep doing that. You can put your calculators back and grab your cell phone.